Hello, everyone. Welcome back to another video. Today, we're going to be talking about similarity. So first of all, we have ratios, and ratios are basically a relationship of two numbers. So 20 is to 25. The relationship between them is 45 and wait, what? 4 and 5. I know 45. And we can say that 20 over 25 is equals to 4 over 5. This is what we call proportion. Proportions just state that two ratios are equal. Now, let's go with the theorems. Theorems, so we have the SSS similarity theorem, which basically states that if two triangles have the corresponding sides of two triangles are proportional, they are um, similar. So let's say that this measures 1, this measures 2, this measures 3, this measures 6, and this measures 2, this measures 4. So let's put them into ratios. So this corresponds to this, so 1 over 2. And then this corresponds to this, so this equals to 3 over 6. This corresponds to this, so it's going to be 2 over 4. So this, once we simplify all of them, 1 over 2 is equals to 1 over 2 is equals to 1 half. So this is our proportion. Since they're all proportional, we can say that these two triangles are similar by SSS similarity theorem. Next, we have the SAS similarity theorem, which basically states that if two corresponding sides of a triangle and the included angle are congruent, then they are similar. So let's say that this corresponds to this and this corresponds to this. Now let's say this angle measures 45 and this angle measures 45 as well. Let's say that this is 3, this is 12, this is 4, this is 16. So uh, let's put them into proportion to check if they're proportional. So 3 is to 12 and is equals to 4 is to 16. Once we simplify that, it's simply going to be 1 over 4 is equals to 1 over 4. And that is our proportion. And since the included angle, or aka the angle between sides, are proportional, are congruent, then we can say that they are similar by the SAS similarity theorem. Then we have AA similarity theorem, which basically states that if two angles of uh, two angles of a triangle are congruent, then they are similar. So let's say that this is 30 and this is 30. Then automatically they are similar because we have 90, 30 and we have 90. Now, so let's have some examples. Let's say that you have a triangle, right? An equilateral triangle, and they have a midline. So a triangle made out of midline. So let's name this triangle to uh, AJC, and then ZO. So basically, we have this is similar to uh, E EOZ. So to do this, since the given is that ZO is the midline of JC, ZE is the midline of AC, and OE is the midline of AJ, we can say that they are all equals to 1/2. So let's do that. So EZ over AC. This is because of the midline theorem. So AZ over AC is equals to 1/2. Then we have AJ, A, okay, AJ, AJ, EO, JAEO, executive optical is equals to 1/2. And ZOJC is equals to 1/2. Now, by transitive property of equality, you can say that all of them are equal to each other because they are equal to 1/2. So EZ is over AC is equals to EO executive optical over JA and ZO over JC. And what we have here is a proportional. And since we have a proportion, we can say that this is similar by SSS similarity theorem. Let's have one more example. For example, let's have bada bing, bada boom, bada bing, bada boom. And that's going to be A, B, C, D, E, F, A, B, C, D, E, F. Wait, this is the hard part of F. The hardest part of similarity, honestly, is like the visual spatial you have to do to make sure everything is correct. D, D, E, F, D, E, D, E, mm, D, E, F. Wait, oh my god, D, E, F. If this is flip, oh my god. If you flip this, can you even rotate? D, E, F. Okay, so baliktad na. Did you know in the math quiz, the image itself was wrong? That's why I couldn't answer. Okay, there you go. So let's give them length. Oh wait, first of all, we need to state that ABC is similar to DEF. That's a statement, man. That's just given. We're not trying to prove that. So DEF ABC. So let's say that this is equals to 2x plus 5. This is equals to 5x plus 5. And then for this one, let's say it's equals to 10. This is equals to 20. So let's make up our ratios. So 2x plus 5, that's that corresponds to 5x plus 5. That's the corresponding side. And 10 corresponds to 20. So that's our ratio. And we can simplify this to 1 over 2 or 1/2. So what we can do here is just cross multiply, which will get us 2 times 5 times 2 is going to be 4x plus 5 is equals to 5x plus 5 times 1. So that's just going to be 5x plus 5. And after we simplify, oh wait a minute. 5x to 5. Huh. Okay. What? Oh wait, I'm sorry, I'm sorry. I forgot to multiply 10. Okay. So 2x plus 5 times 2 is equals to 4x plus 10. There you go. That's why it's wrong. Anyways, we all make mistakes. Okay. Once we transpose everything, we will get 5 is equals to x. And let's find the length of BA and DE. So since our x is 5, simply just substitute x. 5 times 5 equals to 25 plus 5. So this is equals to 30. And for here, 2 times 5 is equals to 10 plus 5, that's 15, which are still in rate or in proportion. Thank you very much.